Welcome, everyone. There we go. Now I can actually see the slides a little bit. So I am Lily Sturmann. I'm a senior software engineer at RedHat. I work on the emerging technologies security team, which means I work on a whole variety of things. And I am also co-representative for RedHat on the CCC's Technical Advisory Committee, along with Yash Mankad. And so I am here today to talk about what's going on at the CCC with our open source projects. So let's jump into that. There we go, slide advancer. So just to set the stage briefly about the Confidential Computing Consortium, for anyone who is not familiar, it is an open collaboration between hardware and software providers and cloud providers, basically trying to advance the use of confidential computing, do outreach about confidential computing, and it is part of the Linux Foundation, so everything done at the CCC is done as part of this open collaborative model, open governance model. All of the documentation, all the meeting notes, everything that you could want to know about the CCC is online. There will be a link for that later in the slide deck if you are interested in taking a look. And I am not going to go into all of the different things that the CCC does. There is a variety. Mike Bursell, who is the new executive director of the CCC, covered some of those things in an earlier talk, and I hope you were able to catch that talk. If not, I am sure there is a recording available that would be worth looking at. But this talk is going to focus on the member projects and how the CCC is supporting those, and then a brief overview of the projects themselves. So one of the most important things that the CCC does is bring in and support the CCC projects. So these are a variety of open source projects that can come from industry or academia. And the projects are really what is accelerating confidential computing. They are building these tools for people to use. They're solving problems in the confidential computing space. And so the CCC really wants to support them in any way that we can. So some of the support that the CCC offers for these projects includes Project Mentor. Whenever a new project is adopted into the CCC, they are assigned a mentor, and this person is kind of a facilitator between the CCC TAC and the project maintainers. So this mentor will guide the project through things like the annual review process, and basically be there as a touch point for the projects. There is also a variety of funding available for the projects to travel to events like this, for example, and for infrastructure and testing. For example, they want to do some testing on specific hardware. There is some budget for that. But the most important thing that I think the CCC does for these projects is bring them into a space where they can have this open collaboration with experts in the confidential computing field. So we don't want the projects to be siloed. They obviously all have really good ideas. This gives them the opportunity to talk to each other as well as to the rest of the Confidential Computing Consortium as a whole, and then also to expand their influence and basically amplify what they're doing to the outside community as well. So that's really the crux of why we have these projects. And there is actually a really cool series of webinars on each of the projects. So if your interest is piqued by the brief overview that you'll get through this talk about any of them, I highly encourage you to go to confidentialcomputing.io, click on the webinar section. There's really good stuff there, and each of the projects will have a little introductory video there as well. let's go ahead and start going through the tour of the current projects. These are in alphabetical order. The first project is the Enarx project. So this project provides a runtime TEE based on WebAssembly. WebAssembly, if you don't know about it, is another cool technology that's worth checking out. It allows a variety of programming languages to be compiled into a WebAssembly target. And this is a project that used to be based in the browser, but has expanded outside the browser with the WebAssembly system interface, which is what Enarx uses. So the thing that means for Enarx is that if you write an application or you have an existing application in any one of dozens of languages that can be compiled to WebAssembly, you are able to run that in the Enarx confidential environment without having to recompile or rewrite your program after that initial translation into WebAssembly. Enarx also focuses on portability and easy migration. So the idea is that you have a variety of hardware environments that you could run on, as well as cloud providers. And it's on an application by application basis. And if your use case changes for some reason and you decide you want to pivot to a different confidential environment, you are able to do that easily. A fun fact about Enarx is last year the team designed a game called Cryptal to show off this functionality. So Cryptal was, if you've ever played Wordle, it's a word guessing game, and Cryptal was a clone of Wordle running inside a TEE. And so users would be able to both submit secret words and also play the game to guess the words. But the other interesting parallel game was that if people could try to write an open source application that could run as root on this host system that was running the Cryptal game to see if there was any way for that program to read out of this confidential memory. And the results, I believe, were presented at DEF CON last year, so if you are interested in seeing how that turned out, you should look it up. I am sure it is an exciting talk. Yes, please, go ahead.
Tom here, he was able to exploit Enarx and win the game.
Yes. Yeah, so definitely look up this talk so that you can see how that happened.
I don't think the recording is online.
Is it not? It should be, because I want to see it. Yeah, so for the audience who did not hear this, the winner of that contest is actually right here in the audience, which is very cool. And if the talk is not online, then I might ask you how that worked. Amazing. All right. So that is the Enarx project. Our next project is Gramine. So Gramine is a library OS that allows Linux or POSIX-based applications to run in non-standard environments, like confidential environments. The main use case so far has been Intel SGX, but I believe there are other environments on the roadmap as well. Gramine does this through the use of something called the platform adaptation layer. So this is an abstraction layer that if you can run it on your host, you can run any Linux-based application in the confidential environment on that host. And the real value add here is if you have tried to write a program to run an Intel SGX without Gramine, you might know you need to write it in C or C++. You need to use the software development kit for that environment and basically write your program specifically for the Intel SGX confidential environment. But with Gramine, you get to skip some of those steps. Again, you don't have to write it in C specifically. It can be anything Linux-based. And you don't need to use the Intel SDK for that purpose anymore. You can just use Gramine and run it inside that environment. So, fun fact about Gramine, I was looking at their blog, and they actually did some really interesting work on debugging and profiling. in the confidential environment. So if you have ever written an application to run in an environment like Intel SGX or any other TE, you may know that debugging it can be very difficult at times. There's not a lot of information that you can get back out easily. And this is especially true if your application runs fine in a standard non-confidential environment, but once you run it inside the TE, maybe something goes wrong. But what is that thing? We all ask this question. So the Gramine team did a really cool job writing their own profiler to try and address this problem. The details are online if you go to their website and their blog. And also, Gramine is compatible with GDB, the GNU debugger, and also a tool from Intel called the vTune profiler, as well as their own profiler that they wrote. So that's pretty neat. Keystone. So Keystone is a framework for architecting TEs for RISC-V environments specifically. It allows you to port the enclave between arbitrary RISC-V systems. And yeah, so this one's a little bit different for that reason. They also allow you to customize the TEs. So there is a base implementation that you can use across platforms, and there's also more platform-specific implementations that you can use. And one specific customization that you can opt into is cache partitioning for additional security. So this is an interesting project. A fun fact about Keystone is that they had 133 academic citations, I believe last year, which was a 28% increase year over year. And some exciting news from this project also is that Keystone is now integrated as a backend for the certifier framework in collaboration with VMware. So if you are not familiar with the certifier framework, there is actually a talk, I believe shortly after this one at 2:30 on track 1, and there will be a speaker there to explain that whole new project, and that is the project that Keystone is now integrated into. So that is something new that they have done that is really awesome. Then we have Oclam. So Oclam is architecturally interesting because it actually has multiple trusted applications running inside the same enclave. So again, the goal here is to allow you to run any application in the secure enclave. As you can see, this is a theme across several of these projects, but Oclam actually did this a little bit differently, and they have a really good graphic that I have on my updated slides that hopefully will be the ones that are published from their GitHub, showing that the enclave itself has multiple ones of these processes. And what that allows for them is, because this is lighter weight, they have a faster startup time and faster inter-process communication between those trusted applications compared to the per enclave libOS processes. And they actually wrote a paper on this that I believe is available online, both about their architecture with the enclave having these multiple trusted applications, and also the complementary approach to isolate those trusted applications from each other inside the enclave. A fun fact about Oclam is that it is actually named after the concept of occlumency from Harry Potter and the Order of the Phoenix. And occlumency in that book is described as the magical protection of the mind against external penetration. And as you can guess, Oclam aims to be the magical protection of your application against external penetration inside the confidential environment. So Open Enclave SDK offers the consistent API surface across these different enclave technologies. So this is multiple Enclave technologies, multi-platform, from the cloud to the edge. And they actually run on Intel SGX as well as Opti, which runs on ARM TrustZone. And Opti, if I'm remembering correctly, is a platform that runs inside TrustZone and hosts these trusted applications, and each one of those applications is inside of its own container. So Open Enclave is able to make use of that environment as well as Intel SGX. One fact that I found interesting about Open Enclave is that it supports Linux as well as Windows, which I actually didn't see on any of the other projects. I could be wrong, but it wasn't there explicitly, so it truly is multi-platform. Veracruz, this one is again a little bit different. So like Enarx, it is using the WebAssembly system interface and is written in Rust, but unlike any of the other projects, it has a very specific use case around collaborative computation, kind of like multi-party computation. So the use case here is if you have multiple distrusting parties, each with their own data set, and they want to combine the results of their data set. They want to compute over the aggregation of all of their data, but they don't actually want to share the data, which could be true in many industries, healthcare, banking, what have you. Veracruz gives you the pieces for how to do this inside the trusted Veracruz runtime. And because this is for a more specific use case, Veracruz actually can be more opinionated about things like the attestation protocol, the provisioning protocol, and other ones of these pieces that some of the other projects necessarily have to leave more broad or open to the user. And that is, again, because this is for the specific use case. So they are giving you these ready-to-go pieces so you can set up this type of computation. And I believe Veracruz works across a multitude of hardware environments. So this is not just Intel SGX. I think I saw AWS Nitro on there. I think I saw ARM, TrustZone maybe, as well as Realms. So this one, again, can really do this multi-party computation across these varying environments. And they have also written a paper that you can find online. So I'm forgetting the name of the paper right now, but I think it is on their website, and it's worth checking out to see how they are making this possible with the Veracruz runtime. Verizon is also a little bit different in its approach. So Verizon, or verification of attestation, this project aims to allow the users to build attestation verification services very easily. So if you're here at this conference, you probably know that attestation is pretty critical. But if not, I will reiterate, and actually the Confidential Computing Consortium recently redefined confidential computing to include attestation in the definition. There's actually a blog post on that, which is worth a read. But so attestation is critical because it is how you know that the guarantees that you're hoping for from your system along integrity and confidentiality are actually present. So you're always going to need attestation when you're doing confidential computing, but you're not always going to need the same attestation because depending on the use case, depending on the environment, you might need very different verification services. The attestations might have different formats. They might have different data included. So when you're doing confidential computing across a variety of these types of use cases, you're going to have a specific custom verification service for each of those. So this can be burdensome, as you might imagine, and the idea behind Verizon is to make it easier to build these customized verification services. So they give you all the pieces to build this quickly, and you can support specific environments and technological backends through plugins. Fun fact about Veraison is that the name actually means the changing of the color of grape berries in wine growing, which is kind of unusual. So that's something that I remember about them. Yeah, so this one is also really important for everything that we do with confidential computing in terms of attestation. So those are our current projects, or the CCC's current projects. But if you have a project or you know of a project that you think would be a good fit for the CCC, definitely do not hesitate to check out the proposal submission template. The CCC tries to make it pretty easy to submit a project. There's basically a 3-step process. The first step is actually the most involved from the project's point of view. Once you submit the proposal template and the project charter, you may have to have a conversation with the CCC TAC about your project, show off its technical capabilities, but that's really the most of it. The submission template includes basic information about the project, the URL, its legal information, the logos, the licensing, and then largely focuses on technical information. So you would need to describe possible synergies or overlaps with other projects, describe the trusted computing base, since after all this is about security. You would need to describe the dependencies as well as any standards that the project implements. And then you would also need to have a few processes in place, like a code of conduct and a security response policy. But if you don't have those things, the CCC has templates for that. So if you're interested in this, it's definitely worth checking out. And it's all open, so there's documentation on there if you just want to look at it and see if it's something that would make sense for your project. If you are curious to know more either about this process or the CCC, there is a booth, which you may have seen, and I highly recommend going by there. There are some really cool mugs. I think there may only be a few left. It's a good place. Another good way to reach out is the CCC Slack instance. If you are also curious about the projects that you've heard a tiny bit about today, again, there is that series of webinars on confidentialcomputing.io. That's a really good way to get a bit more information. But if you have specific technical questions for the project maintainers, I believe many of them are actually at this conference, so I can definitely put you in touch if you would like to talk to them directly. And yeah, that's it. I hope you've enjoyed getting to know a little bit about the Confidential Computing Consortium's member projects.